Hi, we're going to talk about properties of equality today for a few minutes. We've talked about some other properties before. We talked about the commutative property where the order can change. We talked about the associative property where groups can change, and we talked about the distributive property a lot. But these properties are specifically for equality, so solving equations. They're kind of like the way you justify what you did. Well, I could do that because of this property. So we're going to go over them in two ways. First, I'm just going to kind of tell you what they are and a generic version using letters, variables to illustrate it. But I'm also going to give you an example over here that makes a little bit more sense. Please ignore this example. I tried to record this video and my dog started barking. So we're going to start with the reflexive property. The reflexive property means something is equal to itself. So, when you solve an equation, and sometimes at the end you end up with an answer like this, 5 equals 5. That's the reflexive property. And when that happens, you have infinite solutions. Every number would work. So that's kind of what the reflexive property looks like. It just means that, yes, that's true. And it seems silly to have a property named the reflexive property for something that's so clearly obvious, but it is what it is. The symmetric property I like the best for when I end up in a situation like this, -2 equals x or something like that. Most people don't like when the x is on the right. They like it better like this. And so what the symmetric property says is that these are actually the same. It doesn't matter which way you write it. -2 equals x or x equals -2 are the same thing. All right. The transitive property is kind of like a substitution style property. If A equals B and B equals C, then A equals C. So trying to think of like a not math example, but it's not coming to me. So we could have like if x equals 3 and y, or 3, it doesn't matter which way, but 3 equals y, then x and y have to be equal also. Okay. Addition property is just what we use anytime that you move something around by addition. So if you had a problem like x minus 3 equals 4, this part, I'll highlight it in a second, where you add 3 to both sides, that part right there is the addition property of equality. Right here, where you're adding 3 to both sides. All right? Similarly, if we had x plus 3 equals 4, and we have to subtract from both sides, that is an example of the subtraction property, where you subtract. Okay, it's just keeping things balanced. If we had 3x, let me do it this way, x over 3 equals 10, then the multiplication property of equality would be the fact that we multiply both sides by 3. That cancels out there, x equals 30, but you can see in this problem, we multiplied on both sides. That's the multiplication property of equality. The division property is the same idea. Let's say we had 3x equals 12 and we have to divide both sides by 3. That's what it looks like to use the division property. All right. And lastly, the substitution property. We've used this a lot. And maybe not when you're watching this video, but we have, or you will later use this a lot. But if we know that x equals 3 and we have 3x plus 5 as an expression, then anywhere, let me change this to a 4, x equals 4. Anywhere you see an x, you can substitute the 4. That's all that is. All right, so the substitution property is just where you substitute something into something else. All right, so I'll show you how it works with one quick example of an equation that we're going to solve. We're going to do the steps, and then we're going to justify the steps using the properties of equality. All right, so when you solve a problem like this, the questions we normally ask ourselves are, can I distribute? No. Can I distribute? No. But we actually can do something in this step, and that is get this 7 out of the denominator. This means division, like it's 2x minus 4 divided by 7. So we want to do the opposite, which would be to multiply both sides of this equation by 7. When you multiply a side that has more than one term, you must put it in parentheses. That's important. So to do this step, we used the multiplication property. Okay? That's the justification, and what we end up with is 2x minus 4 equals, and I'll just write it so we can do it in another step. All right? So we use the multiplication property of equality to change this equation. Now it's all in one level. Okay? Now again, can I distribute? No. Can I distribute? Yes. So we're going to distribute, and so we're going to write distributive property because we used that. So after we use the distributive property, let me draw my line here, we end up with this equation. Okay, so now we've used the multiplication property of equality, the distributive property. And now the next steps that we have are, can I combine like terms? No. Can I combine like terms? No. Okay. Can I add or subtract something? So you really have a lot of choices here. I'm just going to choose to subtract 2x from both sides. So I'm using the subtraction property of equality. All right, I'm subtracting, so now I have negative 4 equals 40x minus 49. Okay, now we have all of our x's together on this side, so we need to move the constant over to the other side. We're going to add it because that's the opposite. So we're going to add to both sides. So what property do you think we're using? The addition property. Okay, so now we have 45 equals 40x. All right, again, still solving. To get the x alone, we have 40 times x, so we're going to divide both sides by 40 using the division property. You see how it works? It's not too bad of equality. All right, 45, well, we only have x left over here. 45 divided by 40 is simplifiable. Both of those are divisible by 5. So the answer would be 9/8 equals x. And just because some of you aren't super confident about simplifying fractions on your own, remember you can use Desmos to simplify by typing in the not simplified fraction. And right here, that little thing, you click it and it simplifies it for you. All right, so we're done with this problem. We are down to the actual final answer. However, some people don't like the x to be on the right, so you could also change it and write x equals 9/8. If you do that, you're using the symmetric property of equality. All right, I hope that was a good illustration that helps you understand why we have these property names. It's not entirely difficult. It feels really silly when you know what to do, but moving on to geometry and further in math, you need to be able to say why you did something. And so that's where these properties come in handy. All right, have a great day.